So yes, as ma'am said, we will be discussing the building material, the construction portion here, as it covers, I mean, it has a lot of potential that such questions or questions from this part could be asked in exam. I was also going through previous years, so I have been looking into some topics, maybe some topics from where the questions are asked a lot, somewhere some topics which are not touched by DSSSB or DSSSB yet or NDMC yet. So I will give you a brief of this particular subject, but all things we usually discuss or I will discuss along the course so that you should have the idea when you will match these topics maybe with the previous year, maybe the other subjects, you will get to see, okay, such things are there, questions on such parts are already been asked. Then I'll discuss a small part of it. Okay? I'll discuss a small part of it or maybe related questions also which are asked in previous year. Okay. Usually what we do, we start with the properties of materials. Okay, because it has material, it has construction practices or construction techniques as well. So before jumping into discussing a material, like suppose I started discussing stone, brick, or any other material. Okay, the importance of the material comes with its properties. Tomorrow, when you will have to select a material, maybe in practice or anywhere else, the important thing is what property do you want from that material? Whether you want energy efficiency from the brick or you want a cheaper brick. Okay, so maybe you will select the AAC block, or maybe you are going to select a fly ash brick, or whether there are some government implications on that. So there are a number of things, and properties of materials is an important aspect of that. So we start with the properties of material. We discuss a number of properties like what is the volume of the product, what is the density, then maybe electrical properties, their strength, and all such things. Then we move on discussing some materials. So usually we discuss these materials, which are the majorly asked materials like stone, what types of stones are there, how they form, okay, where they are found, how can we use them, what tests that are done on stones. And this pattern we follow in all the materials, maybe the bricks also, tiles or ceramics, lime, cement, mortar, and concrete. Okay, timber, maybe industrial timber products also, and then surface finishing materials. So these important materials we discuss. The pattern almost remains same, how these materials are formed or how we create them, what the tests that are done on material. Okay, maybe some technical aspect of it. Once we cover the material part, we come to the construction techniques. We start with the bottom of it. We start with foundation, like we put a part of substructure. Then we move to superstructure. We discuss what kind of masonry construction are there, what kind of technical terms that are asked in exams, then types of wall, maybe arch and lintels, door window, and all the parts of your building. Okay. Last, we almost finished this modular coordination. While discussing all these topics, for sure, we also discussed the related questions or maybe previously asked questions, some practice questions also. Maybe to test that how much you have learned or how much more or less practice you need. Okay. So what we are going to discuss today? Most of these topics are lengthy, it takes time. Okay. Today I wanted to cover a topic, to take a topic which can be covered in that limited time. Whatever time we have, I want to take a topic which can be covered. So what we are going to discuss today is arch and lintels. Previously questions are asked from arch, not in this exam. In this exam, so they ask a lot of questions from arch and lintels. We will start with the basic functioning of arch, why arches are being used, what are the basic building blocks of arch and its parts. So let us continue with this. I hope you got the gist of it, what kind of things we will be discussing in the upcoming sections, starting with this arch maybe. Okay, this is a part of your building construction techniques. Now again, let's not directly get into it. Okay, arch have bossor, arch have spandrel and all such things. Let's start with the primary function of arch, because the ones we hear term arch, we imagine large span spaces. Okay, maybe aesthetic spaces. So it can be related with aesthetics, it can be related with larger span, and all such things. Okay. It can be of brick or stone or any other building material. Okay, so if we have to discuss what is the primary function of an arch, how does an arch function, why do we look into arch when we have to create the clear span spaces? When we revolve an arch, it will form a dome also. So how does that dome will work? How does it resist its thrust or its load? And why? It provides us the opportunity that we are using a dome or arch, we can create a larger span structures. The answer actually lies in the building block of it. The blocks of an arch look somewhere like this, which is called voussoir. The block of an arch looks something like this, which is called voussoir. And this is this voussoir and its load transfer mechanism that helps an arch or that makes an arch successful. Usually what happens if I have to create a slab, or maybe I am casting a roof, maybe a 3 meter or 4 meter roof I am casting. The roof will be casted flat, it will be a flat surface, casted horizontally. Okay. Might have learned in a structure that these things sag and there is some deflection. We also calculate the deflection. I'm not going to calculate that here. But yes, these things have deflection, then you will have to provide another beam for that support and all. Okay. Because when we have these slabs, each of their particles tries to slide downwards because of the gravity, obviously. They have load and they try to slide downward, which we call shear force. With the shear force, they will try to go downward. And because of this, since each of the member tries to go downward, it becomes difficult to create a larger span flat roof in that context. So how does an arch deal with this situation? They have also weight. They will also try to go down. But what happens with the arches is, the secret is their inclined surfaces. Just compare a block. A block is arranged like this, maybe to create a flat roof. And these blocks are arranged like this, in this manner. The load transfer happens between two surfaces in their perpendicular direction always. When you will push your one hand by your other hand, you will realize the hand which you are using to push another hand, it applies force always perpendicular to your other hand. Okay, so the force always moves perpendicular to the contact surface. So the surface of contact is somewhere here, is for this one, it's here. The force direction will always be perpendicular to this surface. Okay, not in the any other direction also. Okay. Now in this section also, just a minute. In this section also, force, this will try to go down, and this surface, since the perpendicular of it is horizontal, it will not be able to transfer any load horizontally, and this will simply move down. But what happens in the arches is, let me draw it again. What happens in the arches is, when this block tries to move downward, okay, when this block tries to move downward, this block pushes this block. Okay, let me go down. You are in my way, let me go down. In that order, it exerts a force on this block, and that force obviously will be exerted perpendicular to these surface areas. Okay. Similar thing happens. Now this block asks the next block, okay, this wants to move downward. I also want to move downward. Please move aside. It will also exert some force in this direction. Ultimately, what happens, all these forces, I will not get into the components. Forces have components. If you have gone through the physics part of 11 and 12, these components can be broken. What happens ultimately, all these components broke down and the forces ultimately become horizontal. So all these thrust forces, all these vertical forces, the blocks ultimately convert them into a vertical force, and this vertical force is known as thrust. So if I have an arch like this, the complete load will be experienced by this support, and this will try to move this support in horizontal direction. That means that said, this block, this support will experience thrust, or say a horizontal thrust. This block or this support will experience a horizontal thrust. Easily you have all sort of things. You can increase your span. You don't have to worry this block will move vertically. Now if we will relate in domes or in like domes like Notre Dame and such other domes, they have flying buttresses to support these structures. And we have a dome here. Now it will exert thrust here. Now this block can break apart because it is pushing it in horizontal direction. Now to support this, we have abutment, we have these flying buttresses. So that was the reason. Okay. So the secret of arch lies in its building block, and the building block is named voussoir. These blocks are named voussoir. Okay. Now we will get to the arch, we will see key how an arch can be broken, how it will be disturbed, or which kind of forces it will experience. And then subsequently we'll move to parts of arches. So talking about stability of arch, and how an arch will remain stable, or in which conditions it will break apart or it will crush. So the conditions of its crushing or breaking apart could be first one, crushing of arch material. Now, since we know the forces are continuously transferring its force to one another, है ना, ये इस पे transfer कर रहा है, it is transferring this force to another force, ठीक है. So whenever a block crushes, like this block gets crushed somehow, the material was not good, or the material was not proper, the workmanship was poor. So this material, this motor gets crushed. Now, once this connectivity or once this transfer of load gets disturbed, we can imagine that this arch will simply collapse. Second one is sliding of wedge-shaped blocks. Now the condition is same. One of the wedge has slided. That means the transfer of force, the transfer of forces are disturbed. Again, the arch will collapse simply. Rotation about an angle. If the arch or the so rotates a little bit, maybe because of an earthquake or any other region, again the transfer will get disturbed and the arch will collapse. Differential settlement of supports. Now an arch was prepared. There was a support here. There was a support here. One support gets a little bit settled, it moved downward. The moment it moves downward, the complete system will collapse, because again, there will be not enough load to transfer that load from one part to another. So in these conditions, an arch may collapse. Otherwise, they have significant strength. They can bear, or you can create large span structure with them. Okay. Now come to the types of arches from where majority of questions are asked. Like what is abutment, maybe where is the span, what is span, what is the voussoir, what is the keystone. These things, these questions are frequently asked. We will look at the parts of it one by one. Okay. The first one is the abutment or the support. Okay. Abutment or the support from where arch will start. So these supports are called abutment. First one. Okay. These supports are called abutment. Okay. If it moves further upward, it can be considered imposed also. If it further moves upward, it can be called imposed. So abutments, the supports, which can further create imposed. Okay. Second is springing line. Now the springing line is the origin line of arch. Jahan se arch will start. This is the origin line of arch. This is one springing line. This is one springing line. It can be horizontal. It can be inclined also. An arch may start like this also. Okay. The springing line may be inclined. It may be horizontal as well. Okay. But remember, springing is from where an arch springs. It starts. Okay. Span is the clear distance. This is the span, the clear distance that arch provides you. As simple as it is. The springing line, which you can see in the picture also, it's here. Then we have two important points: intradoors and extradoors. Intradoors and extradoors. Okay. Now, if you can see in this arch, it is made of three such rings. 1, 2, 3. There is a lower ring, there is a middle, and there is an upper ring. Okay. The lowermost ring is called intradoors. The lowermost ring. So this is the layer of block. The lowermost layer of block is called intradoors. The outermost layer of block is called extradoors. Remember this. This is not about a surface or some place or something. This is the layer. This layer will be called intradoors. This layer will be called extradoors. Two different layers, two different names. I think intra and extra define itself. Then we have arch ring. So this forms the ring. Curve portion forms the arch ring. Okay. So we already discussed these building blocks. Each of these parts are called voussoirs. Okay. Then another, this point is frequently asked: the keystone or the crown. The topmost part of the arch is accompanied or kept with a crown, which keep all these voussoirs compressed, which keep them pressed, so that they should not tear apart, or they should not slide or something. Okay. It helps them stay at their position perfectly. The topmost part is the keystone or the crown. Okay. We call it both. The crown we discussed. Then we have soffit. Soffit is basically when you will stand beneath an arch. So if this is an arch and I am standing here, I can see the inner surface of this arch, which cannot be seen in this picture because it's an elevation. But when you will stand here, we look upward, you will see this area, this surface. This inner surface is called soffit. Soffit we have in staircase also. If this is a staircase, you will stand below a staircase. The surface which you can see of the staircase, the surface, inclined surface, that's called soffit. Soffit is basically the inner surface of a section. Okay, that's a soffit. If you think you missed something, please you can text, right? Then we have skewbacks and springing points. Skewbacks and springing points. Okay, springing line we discussed. This is the springing line. Okay, this is the springing line. Skewbacks, since it has 3 rings, or an arch may have more than 3 or such rings. Okay, these points from where voussoirs have started, they are called skewbacks. These points from where these rings have started, they are called skewbacks, or different springing points. Like it has emerged from here, it has emerged from here, the third ring has emerged from here. They are the different skewback at different springing points. Springing point in this context, if this is the skewback and we have an intradose also, or we have a soffit also, so these two intersect here. So the innermost point of maybe springing line and the intersection of soffit, so this thing is called springing point. Okay, we have 2 springing points here, one here, another here. Okay, so skewback and springing points. Then we have springer, the lowest voussoir. Okay, springers, you see there are n number of terms. So upon reading twice or thrice, you will get it. So springer is the lowermost block. So here in this picture, we have almost 6 springers. One here, one here, one here, and then 3 here. 3 here also. Okay, we have 9 springers. So lowermost block or the lowest voussoir is called springer. The highest one is called crown or keystone. Now next we have haunch. What is haunch now? We usually divide this ring or this arch ring in 4 parts. Further, when we learn more about this, we'll see that an arch may have 1, 2, 3, or 4 centers. There it will become more why we are dividing it in 4 parts. So when you will divide these arches in 4 parts, each of the part will be called a haunch. Each of the part will be called a haunch. Now, if you will look at it, it is 1/4 of this complete arch ring. It is 1/4 of this complete arch ring, or if we will say half of this one part, half of this one part, or 1/4 of this complete arch ring. The point is, this section, which is 1/4 of it, is called a haunch. Okay, remember this. Then we have rise and spandrel. Rise is basically from the springing line to the uppermost point of soffit. The uppermost point of soffit from springing point. This is called rise. Okay. And then spandrel, basically when we have more than 1 arches aligned, it is called an arcade. It is called an arcade. So these points, it is where these triangular spaces, which you can see, these triangular spaces are called spandrel. Yes, called spandrel. Now, each of these points can form a question. Skewback point, the spandrel, point the rise. And previously, a lot of questions are asked in different exams, okay, from these points. So yes, these are the important parts of an arch, right from the springing line or right from the abutment, the support, to your crown, to your spandrel, more than 1 arch. Yeah. The terms we discuss, the terms of arches we will discuss. Next, we will look at different types of arches. Now, types of arches can be looked in different ways. We can classify arch based on their shape, based on how much centers they have, based on what material they are made of. We can classify arch in different ways. We can. But since we are looking into the building construction perspective, we will see, we look at from that angle only. An arch can be created by created centers. Arch is created by the purpose of centering by created centers. The arch can be created. So here we will look at it from that perspective only, or we will define arches or classify arches based on their different centers only. But we will learn in history or the in history mostly the different names of arch. This place, this arch was used, or during this period, such arches were maybe other perspective you will get in other subjects. Okay. So since construction perspective we are looking at, so we can have one centered arch, we can have 2, 3, or 4 centered arches. We also have 5 centered arches, but they are rare. We may also have 5 centered arches. In one centered arch, they can either be semicircular, segmental, maybe horseshoe, or stilted. Semicircular, obviously, half part of a circle. Segment, not half, but a smaller portion of a circle. Now, you can see both have only one center. Both have only one center. Then we have horseshoe or maybe stilted arch. They also have only one center. Tilted arch, we see from the abutment, it is these blocks is a little bit raised from ordinary arches. Okay, this is called stilted arch. Someone have just like stretched that arch. So these are examples of one centered arch. Then we can have 2 centered arches also. In history, we learned it from perspective of pointed arch. Okay, you can have pointed arch in form of 2 centered arch. In 2 centered arch, we can classify them based on their relationship of their radius and their span. Radius and span. At some places, span will be equal to radius. At some places, radius will be larger. At some places, span will be large. Okay. So 3 such categories we are looking at here. First one is blunt or drop arch, where radius will be smaller than span. Okay, span is bigger. You can see this is the radius of this section, you know, but the span is this much bigger. So obviously, span is bigger than radius. Up, you can see why they are 2 centered arches. This section have a different center. This is a part of this circle. This is a part of this circle. This section have a different section. This is why it is forming a pointy edge here. It is forming a pointed arch here. Okay. Now, if radius will be equal to this span, will form an equilateral arch. Radius is equal to span of it, will form an equilateral arch. If radius is bigger than span, now if you can see this section, this is the radius, but span is this one only. So radius is bigger than this span. Such arches are called acute arches. Okay. So we have acute, we have blunt, we have equilateral arch. I think equilateral was asked once in some of the previously. We have 3 or 4 center arches as well. 3 center arches. Now we'll get the idea why we divided that arches in 4 parts. Now let us divide it into haunches. So first haunch, second haunch, third haunch, and fourth haunch. No? 1/4 of an arch ring is a haunch. Now these 2 haunch, let's name them 1, 2, 3, and 4. 2 and 3 have a similar center here, but 1 and 4 have different centers. So in total, we have 1, 2, and 3 centers. And an example of it is trefoil arch. Trefoil arch. क्योंकि कुछ ऐसा होता है 1, 2, and 3. An example of it is trefoil arch. It also have 3 centers. So they can either be 3 different rings placed like this, or maybe a little bit complex also, like this. Like this have a separate arch, this will have a separate center, these 2 will have separate center, or the 1 and 4 have a similar center, like you can see here, and 2 and 3 have different. So again, 1, 2, and 3 centers. So be careful if we have to judge between these 2 things, whether they have 1 center, 2 center, or 3 centers. While looking at it, you will see whether it is pointy or not, whether is it pointed or not, it may have 3 centers. It's not always pointed arch will have more than 1 center. No, these clean arches can also have more than 1 centers. Coming to 4 center arches, 1. Again, divide them into haunches. In each haunch will have a separate center. You can see each haunch have a separate center here. So yes, these are the things that are mostly arch. Apart from them, we have a flat arch also. Now, if I may ask, we have arch, we have lintels. Nah. Why we are calling this structure a flat arch and not a lintel? We can call it a lintel since it's a flat structure. We can call it a lintel. Why we consider it as flat arch? Anything that you can think of? Any guesses maybe? There should be some reason we are calling it a flat arch, or we have a concept of flat arch. Why we are not calling it lintel maybe, or how can we classify between two such things? Also, very, very, very good. Correct. Very correct. Because from the very beginning, I said the whole concept of arch lies in its building block, which is Vosor, which helps in the load transfer mechanism, which provides the load transfer mechanism basically. Now, if you can see here, these are Vosors. Instead of this, if it would have been like this, so we would have called it simply lintel, not a flat arch. So if you have to judge between these two things, which one can be considered a flat arch or which one will not be considered a flat arch, just go with the very basic. Just go with the building block of it, and it will be because due to the Vosor of it. Okay. Now, material wise, it can be made of stone, brick. We have seen all these. Concrete arches also. Concrete arches may not have a source. Okay, may wooden arches as well. Apart from arches, to create that opening or to support the structure of that opening, we may also have lintels, but the span will not be of that much. We also already discussed we cannot have a larger span on flat thing. Okay, lintels are simpler structures, and it just provide a support above any opening. Okay. So it could be also of wood, stone, brick, maybe steel, RCC also, different types of lintels we can create. Now we have some questions from previous year, these exams only. Maybe to take a minute or two, or maybe less than 30 seconds also you can take. If you know the answer, please try to answer these questions. Okay. The first one is like example of two-centered arch. So which one is an example of two-centered arch? Whether it is semicircular, equilateral, pointed, segmental, or horseshoe. Okay. I'll wait for two more answers, maybe a minute. Okay, so I hope you can judge ki semicircular, be it segmental or be it horseshoe, they all have a single center. Right? Only this equilateral pointed arch where radius was equal to span we discussed, that is pointed arch have two centers. Okay. Okay. Coming to next one, the highest central wedge shaped block of an arch is known as highest central wedge shaped block. Okay. Let's wait for 10 seconds. So see, such simpler problems are asked if you know the thing, if you have, revise maybe twice or thrice. Three revisions are important. In an exam, three revisions are important. You revise, you attempt some problems, then you revise, then you can again attempt, then you again revise, and again attempt problems. This is basically how we cover everything. Okay. So yes, it is equilaterally pointed. Yes, it is keystone, not haunch. Haunch is 1/4 part. Span again, the clear space, and then spandrel with the space between two arches. These also we know. And the next one, the vertical distance between springing line and the highest point of the intradose is known as. Okay. Okay, so as I actually answered, it's not Vosor, it's a building block. Very good. It's not abutment, it's a support. It's not skew back, it is the intersection, it's right. These are from your exam only. Okay, and you have only answered it. So you can see ki, how simpler these things are once you get to it, once you revise it enough. you will have the idea and you will have to answer. Right now you scored almost 3 marks, I guess. Okay. So yes, this is all I have to discuss today. Maybe we'll start from the very beginning. If from the start of course, when the course starts, I'll be discussing the BCM and BCMT and the services part here. Building services, light, sound, the technical aspects of these things. Then the plumbing and all such things I'll be discussing. So these 2 topics I usually discuss here. If from today's section you have something to ask, or you think you want to learn more at some parts, please let me know. I'm open to suggestions or maybe something, whatever you feel.